October 21st, 2016. The MGPI processing facility in Atchison, Kansas. An unintended chemical reaction resulted in a dense cloud containing toxic chlorine gas and other chemicals that drifted into the community, leaving over 140 people with reported injuries. The incident occurred during a routine chemical delivery when two incompatible chemicals, sulfuric acid and sodium hypochlorite, were inadvertently mixed, forming the toxic cloud.
Delivery and unloading operations may be perceived as simple compared to other processes at chemical facilities. But because these activities can involve large quantities of chemicals, the consequences of an incident can be severe. Our case study on the MGPI incident stresses that facilities must pay careful attention to the design and operation of chemical transfer equipment to prevent similar incidents.
The MGPI facility produces distilled spirits, specialty wheat proteins, and starches. The incident occurred in a section of the plant that uses sodium hypochlorite, or bleach, as well as sulfuric acid. These two chemicals, when combined, can form chlorine gas and other chemical compounds. On the morning of the incident, a truck from a chemical distribution company, Harcross Chemicals, arrived at MGPI to complete a routine delivery of sulfuric acid. After reviewing paperwork in the control room, an MGPI facility operator escorted the driver to a locked loading area. There, chemicals are transferred from trucks into the facility through piping, called fill lines, to several large storage tanks in an outdoor tank farm. The MGPI operator unlocked the sulfuric acid fill line for the driver to connect the truck's unloading hose. The operator remembers pointing out the correct fill line to the driver before he returned to his workstation. The driver, however, does not recall hearing the operator identify the fill line. Unknown to the operator, the sodium hypochlorite fill line was also unlocked, and the two lines, which were only 18 inches apart, looked similar and were not clearly marked. The driver connected his truck's sulfuric acid hose to the sodium hypochlorite line, and sulfuric acid began flowing inside. He then returned to the cab of his truck. Shortly before 8 a.m., a greenish-yellow gas began flowing from the bulk tank of sodium hypochlorite. The driver noticed the cloud in his truck's side view mirror and attempted to return to the connection area to turn off the flow of sulfuric acid, but the gas overwhelmed him. He then ran to the passenger side of the truck to close a valve that could halt the flow, but he was prevented from doing so by the gas. Instead, he ran away from the cloud and escaped to a separate area of the facility. At about the same time, toxic gases entered the facility control room through the building's ventilation system. MGPI operators preparing for shift change in the control room were immediately overcome by the toxic gas. Because the operators had a practice of locking respirators between shifts, some were unable to access their respirators before evacuating the building. With no other way to stop the flow other than closing manual valves on the fill line or truck, or by triggering one of the truck's emergency shutoffs, the sulfuric acid continued to enter the sodium hypochlorite tank for nearly 45 minutes until emergency responders shut down the flow. Approximately 4,000 gallons of sulfuric acid combined with 5,800 gallons of sodium hypochlorite, causing a large, dense cloud containing chlorine gas, which soon drifted off-site. MGPI employees were evacuated from the site, and 11,000 Atchison citizens were advised to either shelter in place or evacuate. Over 140 people, including MGPI employees, emergency responders, the truck driver, and members of the public, sought medical attention, some requiring hospitalization.
Chemical distribution takes place on a massive scale in the United States. According to a study by the National Association of Chemical Distributors, more than 39.9 million tons of product were delivered to customers every 8.4 seconds in 2016. The CSB is concerned that there are many opportunities for incidents like the one at MGPI to occur.
John Hennigan is director of the Pipeline and Hazardous Materials Safety Administration's Hazardous Materials Safety Southern Region Enforcement Office.
According to our data from 2014 through 2017, unloading incidents involving hose connections to incorrect tanks occur frequently. These incidents are often quite serious because of the large amount of chemicals involved. Most commonly, the incidents involve compatible materials and result in tank overfills. Incidents similar to the one at MGPI, where two incompatible materials are inadvertently mixed and result in a chemical reaction, occur less often, but are nonetheless problematic. Since 2014, 8 incidents similar to MGPI have occurred. These incidents resulted in 44 injuries and the evacuation of 846 people.
In its case study on the MGPI incident, the CSB identified several human factors deficiencies, which influenced how the operator and driver interacted with the chemical transfer equipment.
Chemical facility operators and delivery drivers often work directly with chemical transfer equipment for loading and unloading operations. The study of human interactions with process equipment, called human factors, should be carefully considered when identifying hazards, particularly because chemical delivery drivers may not be familiar with the facility's equipment.
For example, at MGPI, the CSB found that the close proximity of the sulfuric acid fill line to the sodium hypochlorite fill line increased the likelihood for workers to make an incorrect connection during chemical unloading. The CSB also discovered that the two fill lines looked and functioned identically, using the same type of connections. Lastly, the CSB found that of the 5 fill lines in the unloading area, only one was labeled at the point where the hose connected.
A key lesson from our case study is for facilities to evaluate chemical unloading equipment and processes and implement safeguards to reduce the likelihood of an incident. This should be done while taking into account human factors issues that could impact how facility operators and drivers interact with that equipment.
This can include physically separating fill lines by a discernible distance, selecting hose couplings and fill line connections with unique shapes or colors for each type of chemical, and ensuring that fill lines are properly labeled. Also during its investigation, the CSB found that at the time of the incident, MGPI did not have instrumentation that could automatically shut down the transfer of chemicals from the unloading area in the event of a process deviation, since the only ways to shut down the transfer of sulfuric acid to the sodium hypochlorite tank required human interaction and were located within areas affected by the release. There was no way for workers without proper personal protective gear to stop the flow once it began.
Another key lesson from our case study is for facility management to evaluate their chemical transfer equipment and processes, and where feasible, install alarms and interlocks in the process control system that can shut down the transfer of chemicals in an emergency.
Finally, the CSB found that MGPI's procedures were not aligned with their work practices. On the day of the incident, the operator was not present when the transfer hose was connected to the fill line. Even though the company's procedures state that operators must verify the connection and that the operator should be the one to open the fill line valve, but the CSB discovered that some operators were not aware of these steps in the procedures and that it was their practice to have drivers open the fill line valve, thinking this would be safer, since drivers wear personal protective equipment in the event of a release.
A third key lesson from our case study is for facilities to work with chemical distributors to conduct a risk assessment and then develop and agree upon procedures for chemical unloading to ensure responsibilities are clearly defined.
As the MGPI incident demonstrates, although unloading operations are relatively simple compared to many of the complex processes taking place at chemical facilities, the consequences can greatly impact workers and surrounding communities due to the large amounts of chemicals transferred during deliveries.
Chemicals are transported and delivered every day all around us. Because these deliveries are so common, the CSB strongly urges the managers of facilities and distributors to review and adopt the key lessons from our case study and work together to prevent future incidents like the one at MGPI. Thank you for watching the CSB safety video.
For more information on the CSB's investigation, please visit csb.gov.